Hi, this is Gary Auden, and welcome to this EDUcast from Telecom Reseller, sponsored by Phybridge, the title of which is Eliminating Infrastructure Barriers to IP Telephony Adoption. Gary Auden, and with me is Richard Kasslack, VP Strategic Accounts for Phybridge. Now, you may not have heard of Phybridge, but when you finish this EDUcast, you want to be able to talk to them. And what we're going to be focusing on are these four topics, and we're really focusing on extending communications to desktops for IP telephony. One of the first questions we're going to talk about is your return on investment. Then, how do we plan and then deploy IP telephony, especially when you have cable restrictions or cable length distance restrictions, and how the product we're going to talk about at the end really helps you. We will also talk about eliminating barriers to your deployment of IP telephony, reducing the risk, and definitely reducing the complexity. We have two case studies, one which is New Mexico State University, where they saved over $1 million and reduced the risk and disruption time in deploying IP telephony, which is always an issue we have to deal with. So let's start off. Richard, let's talk about the potential barriers, what gets in our way of IP telephony adoption.
Absolutely, Gary. And you can see on the screen that one or more of these different barriers are causing customers to not move to voice over IP. It could be disruption, it could be the closet requirements, but they all relate to infrastructure readiness requirements, as you can see. And we're going to talk about how we can overcome those barriers to be able to have customers able to move forward without having to worry about these barriers.
One of the things I think is important is some of our audience is IT, not telecom. So they're not that familiar with how digital telephony worked before we went to IP. Can you at least go through that for us?
Absolutely. As we can see on the screen, this is a typical customer in their traditional digital or analog solution. There's an existing digital PBX we have in the example here. Inside the cabinet, there are digital or analog line cards that are terminated on what's called an RJ21 or Amphenol connector, punched down onto the cross-connect cables, the 110 blocks as we see in the picture, coming out of the wall. Out of there into a wall plate. An RJ11 cable is then plugged into the digital phone. What's really interesting here, Gary, is that this topology is found pretty much everywhere in the world. So it was designed to deliver the 5 to 8 nines reliability for voice that we're experiencing today. Whether it's a 110 block or a BIX block, we call it here in Canada, or a Krone strip in Europe and other parts of the world, the topology is the same.
One of the points I think is important for our audience is that the Cat3 cable is not really designed as a data cable, it's a voice cable, but it can go much longer distances than Ethernet. Is that correct?
Very good point, Gary. Absolutely. So the single pair as well is delivering the dial tone on the tip and ring pairs traditionally, and that can run in distances to 1,200 feet or more. Ethernet, as you know, has a 300-foot distance limitation, and that contributed to some of the barriers that we saw in the previous slide.
Let's go into the voice infrastructure a little more detail.
Perfect. So as you can see on the bottom part, we've gone and done what looks like an X-ray into what's inside the building. So we've got some sort of demarcation that comes in that's terminated on a digital or analog line card, as I had said before, and we had talked about the 25-pair Amphenol or RJ21 connector that's connected to a 66 or 110 or BIX or Krone strip. We've got our crossover cable, as we can see, our riser cable, which is that 50-pair bundle. It could be many more pairs. Then we've got our consolidating block. It runs out. There's that wall plate that has a RJ11 cable that's plugging into that digital phone. Dedicated physical bandwidth for every single phone, delivering the reliability, as I said before, that we've all become accustomed to.
One of the points, though, I think in the left-hand corner here is that the data network is segregated from the voice network.
Exactly, and that was done by design. You know, data, again, data has a 300-foot distance limitation. The capabilities, the requirements for data. We try and get as much bandwidth as we possibly can to the endpoint as quickly as we can. Packets are disassembled, reassembled. Packets are dropped sometimes, but that's okay. Data was designed that way. On the voice side, you can't have any drop packets or you won't be able to have a conversation. So that's why the voice topology was designed in a point-to-point type of topology, as you can see.
Now, on the next slide, which I think is very important, is everyone seems to have a LAN, and the LAN is already there. And so many of the vendors out there suggest that you put your data and voice on the same network.
Yes, and you know what, Gary, when the voice over IP first came out, I recall that we were told that we were supposed to try and replicate as best as we can the existing voice topology, keeping physical separation at the desktop of voice and data, because, as we said, voice and data have much different requirements and capabilities. Unfortunately, it was far too costly for customers to go and build out a separate path for voice. So the methodology of what we call daisy chaining, or layering your voice onto a data network, was adopted. Now, as you can see just in the diagram, as those balls bounce throughout the networks, there's much different capabilities there. The data path will travel amongst multiple switches that are connected in this mesh type of environment that you can see. Eventually, arriving at the computer, you see the data path. Packets are dropped, as I said, on the voice. Very seamless. So voice needs very little bandwidth, but it needs dedicated bandwidth, and this point-to-point network was designed for that. So our objective, as you can see, is to bring together and deliver a robust, converged all-IP platform.
I think one of the points, though, that I haven't mentioned is you already have, as a customer, that Cat3 cable running to the desktop where there's a phone already. And most IT people keep thinking, let's replace all of that with Ethernet cabling rather than repurpose or reuse the cabling that already exists. So I think going to bring up next is very important, and that is redoing this whole situation with a IPPBX and a special switching environment.
Absolutely. So if, as you were saying before, if it was capable or we were able to do that in the past, then we would have, but that wasn't available. Phybridge is a global leader in power over long reach Ethernet switching technology. And as you can see in this diagram, if you recall the previous one that showed the PBX on the left-hand side with the digital or analog line card and the RJ21 Amphenol type connector connected to that line card, well, all we've done is we've put our switch in, we've leveraged that existing infrastructure, so we've connected that RJ11 Amphenol connector, or RJ21 Amphenol connector, as you can see on the left-hand side, to our Phybridge PoE switch. We've connected the existing wiring infrastructure, as you can see in number 2. And then at the far end, we've actually unplugged the RJ11 cable from the digital or analog phone that was there before, connected our Phi link adapter, which takes the RJ11 on one end and delivers RJ45, 4 pairs of standard Cat5, Cat6 cable, and plug into the IP phone. So we're delivering power and Ethernet on that existing single pair telephone wiring infrastructure with distances of 1,200 feet or more.
Now, I noticed then in one of the diagrams you showed me 2 different ways of setting this up. Would you discuss those?
Absolutely. Depending on the customer's requirements, you have an option of complete central convergence with the Phybridge solution, which allows the physical separation of voice and data at the desktop, but central convergence in the main data closet or data center. And that would be the diagram that you can see on the left under the central convergence model. As you can see, voice and data are separated at the desktop, converged at the top. You don't lose any functionality. And some customers may require this in a highly secure type of environment, in a healthcare facility, a government office, for example, that's concerned about access or security. This would be a great topology. If you've got a solution or a situation where you've already started to deploy some IP on your data network, but you've come up upon barriers, you can use our solution to help complete the IP migration. We've got a lot of customers in the market in the higher education space that have started to migrate in the buildings that they were able to, but in some of the older buildings that weren't able to migrate, they maintained their legacy digital or analog platform for a number of years. So this solution is now in place to allow that type of customer to complete their IP migration, driving down the costs of having to maintain two separate and distinct voice solutions allows to really collapse those costs and allows the customer to move forward. So no more, and it says right here, no more analog or digital reliance. A lot of large legacy footprint out there in the market today because of the infrastructure barriers, and this will solve that for you.
I noticed one thing, though. You had the IPPX. It would seem that you could also handle remote phones connected to a router to an IP network, and the IPPX can be remotely located. Does that work as well?
Absolutely. This is a layer 2+ data switch, so it would connect into a router, another data switch, directly into the PBX. It's been used in any and all of those situations.
Now, you kind of like the centralized converged approach. What are the value propositions for this?
Well, as we can see on the screen, the reduced infrastructure costs, absolutely. The cabling, we talked about that. The IDF closet requirements, and I'd like to take a moment just to explain what I mean by that, because this is something that's often overlooked and is really a difficult thing when you come to it. So, for example, I was a customer. I delivered a voice over IP solution in my company almost 7 years ago, and what we had from a data perspective, we had our users distributed in 4 floors within a 10-story building. We had 2 what we call IDF or data closets per floor because of the 300-foot distance limitation of Ethernet. So we had 8 different data closets that were delivering data to the users at their desktop. Now, in those closets, we had brooms and mops and filing cabinets and a 20-amp circuit that our switches were plugged into. We didn't have any UPS backup. Because we were a large organization with many, many locations, we decided that those batteries in the UPS backup failed at the worst possible time. So it was better to have a user without their computer for an hour or 2 during a power outage than it would to have those batteries fail and not have someone in place to be able to replace them, because if the batteries fail, they're unusable.
This introduces the switch, the concept that you have. It's a LAN switch, but it's not just a LAN switch. Can you talk about that?
Absolutely. So as it says here, we've got a way to transform that existing reliable voice infrastructure into an IP path that's ideal for IP voice. The difference between a traditional LAN switch and our switches is the connectors on the downlink side. As you can see, we've got our 48-port model at the bottom with 2 of the RJ21 Amphenol connectors. We've got our 24-port model on top of that with a single RJ21 Amphenol connector. So in the slide that you see now, we've got the different capabilities. We've got a management port, just like most data switches do, 2 gigabit uplink copper, 2 gigabit fiber ports, industry-leading power, hot swappable, AC/DC in the same chassis, a 500 or 1,000 watt power supply, depending on what type of power you're applying to it. On the AC side, whether it's 100 or 240 volts AC, and also some unique power management capabilities. The PHY-Link adapter is common amongst all of our switches.
I think it's a point that might have been missed by some. That 48-port and 24-port connector is the one that's already there for the legacy telephony. And so this is really a plug-and-play technology rather than a rewiring technology. Is that correct?
That's right. If you recall from our slide at the beginning, the RJ21 connector, or the Amphenol, is the same connector that's on your legacy digital or analog line cards that you remove and plug right into our switch. So no recabling required, plug and play.
Let's talk about managing this now.
Absolutely. This is a industry-leading management capability. They're fully stackable. We've got customers with hundreds of these switches connected together. It's full duplex Ethernet with PoE and a single pair, as you can see. It has a 10 megabit per endpoint on the downlink side, which is 100 times more than your IP phone needs. An IP phone typically needs about 100K of bandwidth. It does have the uplink ports. You can connect them together for redundancy. We provide the manufacturer's 1-year warranty. And one thing to note is you can see it can be used for more than just IP phones. IP cameras, IP overhead paging systems, wireless access points, door entry systems. Any 802.3AF compliant device, we would be able to provide the power and Ethernet for over that 1,200 feet.
Does that also mean I could put Internet of Things at the ends of this cable?
By all means, absolutely. And this is something that we're seeing a lot of in the market today in places where internet-connected devices are required, but they just have the infrastructure. This is a real lifesaver in a lot of cases.
Let's move forward a little bit more into the switch, and then we'll move into the ROI discussion.
That sounds fair. So as you see, we do have the hot swappable power supply, as we'd mentioned before. There's AC and DC in the same chassis. So in the example that you see on the screen, we've got the AC connector on the left-hand side of the switch, and we've got the DC in and out on the right-hand side. If you have DC backup, you can plug right into that. If you don't, we sell an optional kit. 4 of these stacking cables, as you can see, can be connected together to create a power sharing load balancing ring. And what that means is if you have a power supply that fails or you exceed the PoE budget on one of your switches, the other switches pick up for it. And if you recall, the hot swappable power supply allows us to pull a failed power supply out while the system is up and running, further contributing to that 5 nines reliability for your voice. The web GUI, as I said before, is very intuitive. There's an example on the bottom of the screen there. It provides some capability requirements. It shows you the different devices that are plugged in. It'll give you statistics on the line conditions. Very intuitive. You can actually turn on or off a port remotely. You could lock the ports down to a particular device. So every IP device has a unique MAC address. So if you're security conscious, you could lock the port to that particular MAC address to ensure that no other device is plugged in. And then, of course, all the protocols that you'd expect from a standard Layer 2+ data switch are also supported.
Well, that's an impressive set of things, but you know, we still have to pay for it. I like this ROI chart that you have.
Well, thank you. And we've, gotten these numbers from a number of studies that have been done that show the average cost to get a port ready for IP voice is somewhere around the $400 range. So in the example that we have here, these are the key things that a customer would need to do if they were looking to move forward to voice over IP. And what we're going to do is compare a without Phybridge on the left and a with Phybridge on the right to really drive home the value that we're talking about. So first and foremost, whenever you're doing this, you should do a LAN assessment. And the average cost for that is somewhere around $10 per user. And from a return on investment to the customer perspective, there's really no return on investment with that. The closet costs, and we talked about that briefly, the backup power, the cooling, the increased power required for those IP phones, that's somewhere around $60 per port. And again, no ROI contribution. Cabling, global average we found is about $150 per cable drop. No ROI contribution. Services, about $75. PoE switch port is about a $50 premium over a non-PoE switch. So the customer is going to spend, in this example, $345 just to get that port ready for voice. There's no additional functionality or capability or ROI contributing factors in this scenario. Now, if you flip it over on the Phybridge side, LAN assessment's not required. You've got the voice working on your traditional voice. It's going to work with the Phybridge solution because we have that physical separation at the desktop. Backup power, cooling, power source. We're placing these in your telecom closet, 1,200 feet away, where you've already got your concentration of backup power and cooling and power. And if you do need to spend, it's 1/6 of the cost of having to do it in all those distributed closets. The cabling, not required. The services are much less. So what we've done is we've decreased the cost, as you can see, from $345 to $155 per port, leaving more than 50% of the budget that the customer was willing to spend on things like better phones, better ROI driving applications, like call recording, like mobility. These are things that really contribute to the customer's return on investment.
I think that leads us very nicely into the New Mexico State University story, which saved $1 million and was also a very rapid deployment.
Absolutely. The customer we met at a show, we were introduced through one of our partners. We decided that they were a perfect candidate for what we call our proof of concept program, which we run. We provided one of our switches. The customer was able to test it and deploy it in their own environment. They found that it worked seamlessly. So they decided to do an apples-to-apples comparison. They did their library with a Phybridge solution, which had about 230 users, and it took them 3 days to deploy. They did their IT department on a traditional voice on the data LAN deployment, and it took them almost 3 weeks. So the time savings was astronomical. And when they looked at the actual physical costs, they ended up saving in excess of $1 million and have deployed over 4,000 IP phones on our backbone. That project was going to be anywhere between 5 and 7 years, and they've completed these 4,000 phones in just less than a year and a half.
But I think there's another example in the TransUnion is just how fast you were able to get 1,400 users working.
Yeah, it was shocking, actually. The customer told me his plans, and we said, you know what, sounds fair. And some of the highlights of that particular customer, as you can see on the screen, it was 1,400 users. The customer had just gotten to do the activities that we talked about before, the LAN assessments, the cabling, the power, the backup, all of that in the data closets, and it was somewhere around $1.8 million. What they found with our solution, it was going to cost about $300,000. So they were saving right out of the gate almost $1.5 million. And what they did, same concept. They did a proof of concept, tried it out in their environment. They knew exactly how long it was going to take them to deploy, and they actually deployed all 1,400 users in a single weekend. That's shocking. That was going to be a 6 to 18-month project as they moved users around within the building, as they did their rip and replace renovations. It was going to be a much longer project, a single weekend. And the nicest thing of all, they took that $1.5 million savings and allocated it to applications that drove a better ROI for their users.
I think it's important also people just take a look at this slide for a moment about the recognition and the awards you've garnered by putting these solutions out in the field. But I think what we also move on to what you really do. What's sort of the summation of your system as a resource?
Well, as you can see, when a customer is looking to move forward with IP telephony, there are five key components that everyone needs to consider. First and foremost is ensuring a good user experience. They need to have at least as good or better quality of service and reliability that they had on their existing platform. And because we leverage that existing infrastructure, we can guarantee that. We eliminate and reduce financial risk. We know exactly how many phones they want to migrate. We have a cost per switch and adapter, so we can provide the not to exceed pricing for the customer when they're budgeting and planning. On a voice on data deployment, that's not always the case. As you start to go in and pull wire, you may come across some barriers, you may come across asbestos, things like that. So that's a risk that we can eliminate. The quality of service, that's absolutely paramount. Voice continuity, if the data LAN fails or has an outage, to continue voice, that's very important. Non-disruptive to your users, easy to manage, future-proofing. And this is one I'd like to explain more in detail. You know, I ask customers, would you believe or would you agree in the next 10 years that you're going to need more bandwidth for your endpoints, your computers? And every one of them overwhelmingly tells me, yes, I believe I'll need more bandwidth for my computers in the next 10 years. If you're using the phone as a point of convergence, that means that every time you refresh your data switches for more bandwidth, you need to buy new phones, because the phones are providing the connectivity to the computer that's plugged in if you're using the phone as your point of convergence. With our solution, that's not the case. And finally, brand protection, making sure that you're on budget and on time. I think these are the key things that we can bring to pretty much any customer. As you could see in the previous slide, we have over 250,000 and growing.
What I'd like to point out to people is there's some good resources here. The first one is the New Mexico State University video, which is actually a discussion from those individuals at the university about what happened. Some blogs are available. There's Phybridge TV. Here's some contact information for you to get more on what Phybridge offers. So I thank you, Richard, and I thank the people for listening, and we are finished.
Thank you, Gary.